All right. Hi, guys. So today we're having the fourth podcast series of the data science YouTubers. And so today we're having Ken Jee, Dhaval, and Krish. Yeah. So would you like to introduce about yourself, please?
Sure, I don't mind going first here.
Yeah,
So
sure.
hello everyone, my name is Ken Jee. I'm the head of data science at a small sports analytics focused consulting firm based out of the Washington DC area. So we use the data that's collected on players and teams to help them improve their performance, basically improve their winning percentage. I also have a YouTube channel. I've done some collaboration with Shannon in the past, where I focus on how to get into the data science field, a little bit about sports analytics, and also data science projects. So, it's always fun to do these conversations, and I'm looking forward to the topics we're discussing today.
I'm Dhaval. I work in Bloomberg as a data engineer, and I also have this YouTube channel called Codebasics. So that channel focuses mainly on programming, and recently I have started doing a lot of data science related projects and tutorials, etc. And it's always fun having conversation with you all. We have been doing this for past 4 or 5 weeks, and it's been a great experience so far.
So hi, my name is Krish. So guys, as I work as a lead data scientist in Panasonic IAC. Apart from that, I upload a lot of videos in my YouTube channel regarding machine learning, deep learning, and all the projects, and any new thing that comes up. Apart from this, yes, we are collaborating and probably are planning for collaboration every week. And that's it. I guess most of our audience knows each other, like as a group, we have been uploading these videos and all.
I think next video we don't have to introduce ourselves anymore.
Yeah, exactly. That's what I was going to say.
All right, guys. So today we're having the theme of tips on building your data science portfolio. So I think the common theme for all of our four YouTube channel, we would recommend students or beginners of data science that when learning data science, it is very important to implement data science projects. And so how do we get started in developing the data science portfolio? How do we get started in developing data science projects? So that will be covered in today's discussion. And so before we begin, maybe a brief fundamentals on some of the reasons why we should implement data science project and how will this help in our learning data science. So Ken, would you like to start that?
Yeah, so I think the reason you should do projects is for two reasons. So when you're working with examples of code, when you're actually applying the technologies, I believe that you learn a lot faster. So if I'm reading about creating an object in Python versus actually doing it, I think when you're doing it, you just internalize it so much more effectively. So that goes the same with any of these data science algorithms. Is when you apply it and you see the results of the model, you intuitively understand a little bit more about how it works than just working off of it conceptually. In addition to that, when you're doing these projects, you actually have something to show for your learning. So when you take a course, maybe you get a certificate, but if you have an actual model that works that can predict something, one that to you should mean more because you have a tangible thing that you've created through this coursework that works, that predicts, does whatever. But it also means a little bit more to recruiters or to managers because they can see that you actually understand the concepts enough to apply them. So I think that those two elements are what really drives the value of projects from the learning side, but also for the recruiting side. I'm a firm believer in showing rather than telling, and projects are the most clear-cut way that you can do that.
Okay, Dhaval?
Ken summarized it pretty well. I will add just one point, which is if you are starting with a data science learning, the amount of topics that you have to learn are humongous. Actually, you have to go through math, statistics, machine learning, programming. There's just a lot to learn. And if you're doing project, what you're doing really is you're giving that mental reward to yourself. Unless you do something to give yourself a mental reward, you will probably leave that journey halfway. Now, if I do, let's say project, I recently did this project on a sports celebrity image classification. So when you have that website working in front of you, that is something tangible, which you can show it to people. It kind of gives you motivation to continue further. So doing this projects intermediate will give you a lot of mental boost. And for that reason, it's very important.
Mm-hmm. All right, Krish?
Yeah, as I say every time that data science is just not about model building, we need to find out a way where we can actually develop that as an end-to-end product where at least people should be able to see what it actually does. Then only the importance is given to your skills, when they're able to see that particular product, okay, it works like that. Yes, machine learning building models is also important and all that are the internal things where you can improve regularly, but end-to-end project is pretty much important when you're doing that implementation, and make sure that you follow all the life cycle of a data science project when you're doing that, so that if you're explaining anyone, I think that covers most of the thing, and it'll be easily be able to understand for a layman person also. Apart from that, I think all the points has been covered up by both Dhaval and Ken.
Right, excellent. So let me add a minor point. So while you're doing data science projects, I think that that would also be a great opportunity that you'll also figure out topics that you want to learn more. So as Ken and Chris and Deval has mentioned in previous discussion, the importance of developing this minimal viable product, right, Ken? MVP, right?
Minimum
So
viable knowledge.
yeah, exactly. So the thing is, once you develop this product and it's working, and then you want to make more improvements to it. You want to make version 2 or version 1.1. So with each improvement, you have to figure out how would you like to improve your project. Would you like to use additional feature? Would you like to modify the algorithm, and how would you like to do that? And so in doing that, you would incrementally learn and you'll build your data science skill. And aside from that, like when you're doing either a bachelor's, when you're doing an honors, right? Or if you're doing a master's or a PhD. So the essence of these studies or degree, it's not in the coursework that you're doing. So the essence is in the capstone project. It's in the thesis project. And so under the hood, each of these will require you to do an extended time where you spend time to do and work in projects. And so essentially, when you're working on project, you'll get to familiarize yourself with all of the key elements of the data science lifecycle, as Krish has mentioned. And so I think that's a great opportunity to learn and mature. So yeah. Okay, so let's move on to the next question. So this question was suggested by Grish. And so how can doing the data science project benefit freshers in their job search? So can we begin with Grish?
Okay, suppose if I take one kind of stream where a person is actually in the college, right? The third year or fourth year, when he's implementing those kind of projects, usually they get an opportunity to do internship. What I think is that internship can play a very important role in any student's life, because at least they'll be getting that experience to work in a real world industry, basically for a real world project itself, which is pretty much important. It's just like a start for a person where he'll be able to understand how things goes in IT company. And once he's able to get that, probably he will also have opportunities where he may get hired for that specific companies also. Now the major thing is that companies, how they are looking for people so that they can actually hire them as internships. So as interns, sorry. So what they focus on is that at least he should have some basic knowledge of implementing some of the things, right? So if he has already implemented a data science project, and I'll also add this, that he should also be able to put some additional efforts to contribute to the open source projects. Even he can actually write blogs so that he can give back to the data science community and do all these kind of activities. So that definitely will add up as a wonderful thing in their resume when they are getting hired as interns. So it definitely works. It actually plays a very important role for a student's life, in student's life.
Okay, Dhaval?
Yeah, I think we have discussed this before as well. So projects are super important, especially for freshers, I would say, because if just think from a recruiter standpoint, when they look at your resume and all the projects that you see is maybe Boston house price prediction, I mean, it's not going to impress them. Versus if you have worked on a real data set, real problem, it kind of shows that you have put your genuine effort and it increases chance of getting interview calls. And while doing these real life projects, you can also build some of the skills which you won't be able to build when you are working on those kind of like dummy projects. And sometimes people ask, like, how do we even get these projects, because it's hard to get internships sometimes for everyone. So there are like some non-traditional ways, such as open source contribution, going to an NGO and offering your help, to maybe your relative who might have some business for free. So we need to be really creative when you're looking for like a real life projects. And once you pick those projects, just put your effort, and it's gonna benefit you on all different fronts.
All right, Ken.
So I think one element of projects that I don't think we've mentioned before is how important they are for telling your own personal story. So as much as having the technical skills are important for getting your first job, it's also important to explain why you're there and why you're interested in data science. And if you're coming into your first job, if you're a fresher, if you're very new, you don't have that much to talk about. Maybe your education, maybe some of these other things. You can carry on a whole conversation about one of the projects you've done. You can explain the logic, the reason why you made certain decisions. Having anything extra to talk about that you're really interested in, that you're really passionate in, is something that can greatly help you along the way. If the person interviewing you is also interested in your topic, maybe it touches on an area of life that they're also interested in. Maybe it's on, like a certain genre of music and classifying songs or something. Or if it's related to the work that the company does. Being able to talk on that and show that you've developed some subject area in whatever domain your project is in, that is so powerful and so compelling for someone to hire you. Because that's what you have to do when you go on a job, is you have to learn this new domain, you have to be able to explain it, you have to be able to work on it, and then you have to present it. So you're showing that you're doing these real world examples of what you'd be doing in the workforce. And again, that storytelling, that element of being able to talk intelligently about your work is something that can go so far and really help you with your job chances.
Great. So all of you guys have essentially covered all of the possible answers. And yeah, so maybe reiterate in the next question. So let's move on to the next one. So what are some of the important aspects that you would consider when creating a new data science project? So sometimes I see this a lot. So the thing is the trade-off between, should we focus on creating more projects, or should we focus on creating few but perhaps higher quality project? So essentially it's quality versus quantity. What do you guys think? So could we begin with Chris?
Okay, so what I would suggest is that quality is pretty much important. Now, when I tell about quality, I'm considering all the life cycle of a data science project, from data collection strategy, data storing strategy, then creating pipelines for each and every life cycle, like feature engineering, feature selection, model creation, hyperparameter tuning, then model deployment. When you're doing model deployment, probably use or learn Dockers and Kubernetes. It will help to make your model quite scalable. Use these techniques and actually create it. It may be one or two. You need not create many, but if you're trying to create, make a quality one, and choose a very interesting domain, the domain that you are actually interested in, so that you will be able to learn some things. Like suppose if Ken knows a lot of sports, so probably he would like to work in a sports domain, so that way, or he can also select some other domain where he's pretty much interested in. By that way, he will be able to also explain the recruiter in much more better way, because he will be in the comfortable zone. Whenever anybody asks related to that specific domain, he'll be able to answer, like why he has done that, why he has not done that, with all the steps that he has actually taken. So I think quality is pretty much important, considering you have to follow all the life cycle of the data science project, plus interesting domain itself. I would suggest in that specific.
Okay, Dhaval?
I'll just add to whatever Chris mentioned. Let's say if you're in New York and looking for a job, New York is all about finance. There are so many financial institutions looking to hire new graduates. So if you've done a project in finance domain, it kind of increases your chance, because then the interviewer who's talking to you will have a common theme or common topic. You know, it will be making it more compelling, as Ken answered in the previous question. Also try to, I will definitely go for quality, fewer projects, but more in depth, and try to cover different aspects, right? Like the feature engineering, data collection, model building, the same list of topics that Krish mentioned. Try to cover like deep learning models as well, and non-deep learning, and try to use some of the enterprise frameworks, such as Amazon SageMaker or Google Cloud Compute. So if you uh, cover different topics, as well as if you have used these enterprise tools which are used for machine learning in different institutes, that's gonna look really impressive on your resume.
All right, Ken.
So I agree 100%. I think that you should have at least one or two projects where you do a really in-depth end-to-end data science project. That shows that you can use all those tools, and you can go deep, not just broad. I also do think that as long as you have one of those end-to-end ones, you can also sprinkle in a couple smaller ones, because in the workforce, you're not always going to be doing a end-to-end project. Sometimes you're just going to be doing an EDA. Sometimes you're just going to be doing collection and cleaning. Sometimes you're just going to be doing the model building. So you can sprinkle in a couple of these other ones, as long as it's very clear what the use case and the value is. So, you know, one thing in the README of a lot of projects that I recommend is like, what are the goals of this project? If you can meet the goals in just a few of the steps, that's okay. As long as you've already shown in another project that you can do the breadth of the data science lifecycle. So I think that's the only thing I'd really add there, is you want to make sure that you can show your kind of flexibility there, but you definitely need that one, at least that one project where you go from end to end. I would also add that you want to have some diversity of the types of projects you do across the different types of data science algorithms that are out there. So, you know, at the very minimum, I think in one project you should do classification and compare some of the different classification algorithms. One project you should do some clustering, and another project you should do some regression style problem. And I also recommend having at least one project where you're doing deep learning, NLP, computer vision type stuff. Those I kind of group into a bit more advanced topics. So, you know, you don't have to know every algorithm or every tool under the sun, but just show at least once that you can go in depth, and show that you have knowledge of all of the main tools that you use on a daily basis in data science.
All right, excellent. So
I would like to add one
sure.
point. So again, like when we are having discussion related to data science, you know, we are not only talking about data scientist role. There are other roles, like data engineer, for example, is a very important role in the field of data science. So now if you're data engineer, your job is to deal with the database infrastructure where data scientists come and they can build model on top of it, right? So you might be having a Hive cluster or like any big data infrastructure that you're managing. So in that case, you might have a typical database or software engineering type of project. So it depends. And trust me, many times like data engineers get paid much more than data scientists actually. Sometimes people don't know about these facts. So you have to really think like where your interests are, and then what type of career you are targeting, and try to do projects based on your end goal.
Right.
Yeah. Well,
awesome.
one thing I'd like to add to that is that, you know, if you're in the data domain, you should be using data as much as possible to drive your like job search process. You know, one thing that I recommend, and I don't see a lot of people doing, is just go online, find 20 job descriptions that you're interested in, where you're like, wow, this job would be really cool, and look at all the tools that they use, right? If you see a tool coming up 3 or 4 times, maybe it's worth learning that or doing a project on it. You know, that's a data-driven approach to like learning the proper tools for the jobs that you want. And, you know, a lot of people are just asking. All these jobs are different. Find the ones that are relevant to you and go in and learn the things that are relevant to get those jobs. That to me is like, that's how a data scientist, a data engineer, data analyst would think about the hiring process.
Yeah, awesome tips. Yeah, so as all of you guys have already mentioned, so the thing is to properly perform the data science lifecycle and to also showcase your data science skills and capabilities aside from the technicalities. So you would also need to do some show your soft skill aspect as well, like communication, your ability to convince, your ability to convey what novelty you are presenting. And another thing would be perhaps to introduce some novel tweaks to existing machine learning algorithms, increase maybe the performance of the algorithm, perhaps improve the interpretability of the model. Like for example, I'm working in the field of biology, and the thing is, we have to convince biologists or chemists of our prediction model. So how can we do that? So we have to use features that biologists and chemists are aware of and they know and they understand. So the thing is, sometimes we're using very complicated models, but at the end of the day, they cannot take anything out of that. So we have to figure out. So the challenge is, how do we create meaningful models? So it doesn't have to be based on sophisticated learning algorithms, but it could even be based on like simple like decision trees or linear regression. And the thing is, how can we simplify that as much as possible to the stakeholder so that they could move this, make use of this data and to drive actionable results. Yeah. Okay.
I'll just add one quick thought.
Yeah.
There is this idea of reproducible research. So I was attending this JupyterCon conference. I've been attending that conference, and I have met the creators of Jupyter platform. You know, my company Bloomberg is officially funding Jupyter project, and some of the core members are actually, they are kind of my friends. So what they say is, when you have a Jupyter notebook, see, nowadays, even if there is a biologist or data analyst, there is this trend that you need to know Python at least. Okay. So there could be a biologist whom you can hand over that model, and when you hand over the model, maybe hand over the Jupyter notebook as well. So you can do this reproducible research where you can feed your own data and kind of check the performance on it, or maybe you can tweak it. So, you know, like that way, the Jupyter notebooks are really, really powerful. You can have it on Google Colab and share it with your friend. And if he's not satisfied with your answer, he's like, okay, this is the reproducible code that you have. Try with your own data set and see how it performs.
Yeah, exactly. So like recently in the last year, I've written 2 articles with our colleagues in our university. So one article was published as a book chapter. So we proposed using Jupyter Notebook as a reproducible medium in order to put all of the code, and other scientists can take that code, modify the input data, and reproduce the entire workflow. And we've also written another review article where we go through the literature. And the interesting thing is that we found that in computational drug discovery, a lot of the research are done using like traditional point and click software. And the thing is, when they're describing the work, they're doing it at a high level. And so the underlying like parameters, or, you know, like even adjusting the random seed, they don't even go into such detail. And so the reproducibility of such work is next to zero. So with the advent of Python or R and Jupyter Notebook, as you have mentioned, I mean, it's a game changer. And so now scientists are now able to upload these notebook online, as you mentioned, Google Colab. And interestingly, there's another platform called CodeOcean, where you could upload Python, MATLAB, R, Julia, and then someone can just log into that website, CodeOcean, and then run the entire workflow. I mean, it doesn't have to be a notebook. It could be a Python file, and all of the dependencies already right there. So yeah, that's a very important part. Yeah, thanks. Anything from Krish?
No, I agree with all the points that you are saying. I think it is pretty much covered up.
All right, perfect.
All the important things.
Awesome. So let's move on to the next question. So from all of the data science projects that all of you guys have worked on, could you tell us what is your favorite one? So that question was proposed by Ken. So let's start with Ken.
Yeah, so I think my favorite one that I've done recently actually is the data science project from scratch series. that I've done on my channel. So basically, I think I made 7 or 8 videos where I walk through each step of the data science lifecycle. And to me, that's really valuable because the project is focused on understanding data science job descriptions. That's something that's relevant to my entire audience, that's relevant to everyone watching. And I think that what's important there is like, I'm doing a project that I think would really provide value to someone that's tangible, right? I mean, we talk about, you know, how to communicate value in your projects, because that's what business stakeholders are always looking for. And it's all also about asking like the right questions and being able to understand who this analysis would help. Like, even if it's helping yourself understand something better, that's totally fine. But we should be starting kind of at the end of these projects and thinking, okay, what do I want to determine? What do I want to solve? And then work our way back. I think a lot of people get really stuck with projects in general because they don't know where to start. I mean, in general, there's 2 ways. You can start with a problem and say, I want to solve this. I'm going to go out and grab that data, which is what I did in that project. Or you can start with the data and say, okay, on Kaggle, there's all these data sets. This is really compelling to me. I want to do something with that. And so, you know, the thing that I like about that is I documented it in a very different style than I've ever done. You know, usually I just put things on GitHub. I don't actually have to talk my way through a project. And that was a very new thing for me. And I think it helped me understand all these concepts a lot better as well. So when you're doing these things, part of documentation, part of producing reproducible code is that you actually learn it better yourself. I don't think in my entire career, I've done a project where I've learned more than just that one, because I knew other people were going to be watching it or like looking through it. And it really put additional pressure on me to understand the concepts and to be able to explain it. So, you know, I think the big takeaway there is that when you're doing a project, share it. It doesn't have to be on a video, but if you know other people are going to be looking at it, you're going to always put that little bit of extra effort in to make it a little bit cleaner, to make sure you know what you're talking about, so you don't get, you know, crucified on the internet.
Right. Okay, Dhaval?
So I have done many cool projects in my company, but unfortunately, because of the policy, I won't be able to share details on that. But if you look at my YouTube project, recently I did this sports celebrity image classification. Image classification is a very like a boring topic, but then I love cricket, I love tennis, and I love soccer. So I just picked 5 of my top sports celebrities, and I just made an image classification on that. Now, if you're talking about image classification, you always think about CNN and things like that. But I wanted to show it to viewers, like how you can even achieve more than 90% accuracy, even with a simple like SVM or logistic type of regression and using like the wavelet transforms. So that project was pretty cool because it's image classification without neural network, and you still get more than 90% accuracy. And I had a friend of mine who is a data scientist in Amazon. He helped me with that project. I learned a lot about wavelet transform and like signal processing and things like that. So it's like, as a YouTuber, I think we all feel the same way, that we are also learning new things, you know, as we build these projects. One other project I'm working on, which is going to be even more interesting. It's going to be ideal for data analyst, where I will be doing sales analytics, sales insights, basically. So if you have a company, you know, and they have branches across the country, different regions, and you have sales going on, sales are declining, you know, your sales director is under tremendous pressure. Like, how do you use the power of data analysis to get some real insights by building some powerful Power BI dashboards? So in that project, I want to give a glimpse of what exactly happens in a big corporate company. So that project will be coming up soon. So those 2 probably are my favorite projects.
All right, awesome. Krish?
So probably the most interesting project, most difficult project is the project that I'm doing right now in my company. As I told you that it is going for the patent, and this is all about, I've written some custom algorithms for pattern recognition. So trust me, like why I'm saying it is very much difficult, because 1 week I had just sat idly. I did not have any clue what to do. You know, I was stuck in completely in between. I had no ways. I have to think how it has to be done. So finally, I got some points, did a lot of research, and finally, I was able to do it. So probably that paper, once it comes out, I'll definitely be sharing. Apart from that, in my YouTube channel, I've created one project. Uh, it looks like a whole real time project itself, because that project name is predicting air quality index. Okay. Now, air quality index, how major thing is that we need data. We need data from past 4 years, 5 years, 6 years, right? So that data, probably from one website, we have scrapped that whole data, taken that particular data, stored it in some database, did all the pre-processing, there were a lot of null values, this, did everything clearly step by step, and did each and every step, then applied on top of that 8 different algorithms, found out the best algorithm. So what all an auto machine learning algorithm, that is automated machine learning algorithm, does, I have done it manually, creating pipelines separately. Probably if you use PyCaret, it will do it in one step, all the things. So the main reason why I created that particular project is to make people understand what all things actually goes on. Some of the automated libraries will not work for every data sets. That particular data set was pretty much complicated, so I had to go and do all those particular steps. Apart from that, the n number of projects I've uploaded in YouTube channel again. But every time I remember always about the AQI project. So
Right, awesome.
like that.
Yeah. So for myself, so essentially all of the work that I'm doing right now in my work is essentially about drug discovery. So I've done this bioinformatics from scratch series, and this was inspired by Ken Jee as well. So I saw that he had this cool eight-part series, and I'm like, okay, maybe we should also do the same thing. And so I did, like, I think so far we have 3 parts already. So we did some EDA, we did some data collection, and some data pre-processing. And so part 4 is yet to become. So I have yet to film that. And so essentially it's pretty much about like drug discovery. How do we convert a molecule, like a drug that we normally would have orally intake, and how can we modify the chemical structure of such drug so that it will have less toxicity, it will have more potency. And so the thing is balancing between the two, because the thing is, in order to kill like cancer cells or antimicrobial, to act as an antimicrobial drug, it's very difficult to have it, kill the bacteria, but also be safe for the human, because it's very challenging in that the protein target that we're targeting sometimes is present in both humans and in bacteria, because it could be like 70% or 80% similar. And the thing is, there will always be a side effect. And you're taking one drug, and the thing is, it might have other side effects that you might not be aware of because maybe we haven't tested it in experiment. So yeah, so I think that is an awesome project that essentially is following the same theme. So one project after the other is following the same theme of drug discovery. And yeah, so we have
Are
a
you
great
going
team.
to be any project on corona vaccine whenever it comes up?
Oh, corona drugs. Vaccine is
Yeah.
a much more complicated. So that would have to be involved with like taking fragments of the antigen and then taking that and then applying it to humans. So that would require experimental work. So more maybe perhaps on like coronavirus drug. Yeah. But currently there's only limited data that are available in the database.
Yeah, but within next year or two, maybe there will be huge collection of data, and maybe we can all do one project on this combinedly.
Yeah, sure. Yeah, actually, that's an interesting thing. Aside from coronavirus, there are other similar viruses. So like, there are like, I think it's IBV, something to do with bronchitis virus. So they're very similar. So the thing is, the coronavirus protein, if we do like a search, there are like maybe 5 or 6 similar viruses having similar structure. So potentially we could harness the already available data and available drugs for those, and then maybe modify the compound and then try it for coronavirus.
Yeah. I always wonder if data science can help whenever the vaccine comes out, because I have a friend they do a lot of research and finding vaccines and all that. And they
Right.
say like the best case is like 2 to 3 years. If
Mhm.
they get vaccine developed in 2 to 3 years, they will be doing party. And
Okay.
they're trying to develop this corona vaccine within a 1 year time frame. I'm like, what if that vaccine has a side effect, which shows up after 6 months or
Right.
1 year? Then you're kind of too late. And that's one of the big concern right now in pharma industry. So I'm wondering, I always think like, that if the existing research and data science can help in making predictions on those factors.
Right.
I think with respect to this corona drugs, I think a lot of things are going in Kaggle kernels also I've seen. A lot of people doing some of the other things over there. So just recently I saw just a week back. Because of that, there's a huge demand for that, like many subscribers are basically saying that please upload a video regarding that. Probably we should try to plan for that also.
Yeah. Or we could collaborate on such projects.
Coronavirus hackathon.
Yeah.
I recently opted in. So you guys see this ring I wear? It's like a sleep tracker. It does body temperature, all that stuff. And for the NBA, they're making all the players wear it. And they say that they can generally predict if they have the coronavirus up to 3 days before symptoms start using by monitoring all their vital signs. So I think UC San Diego in California is collecting all this data. I opted in to be used and do the antibody testing and all that stuff.
Awesome.
It'd be interesting to see if they would publicize some of that data and anonymize it and do a little hack on that. That'd be pretty cool.
That would be.
Are you able to get that particular data, like your patterns, whatever?
I should be able to get my own data. I mean, it's just daily data though, so I don't know if it'd be as useful. And I'm pretty sure I don't have the virus, but
okay.
Yeah, I think that would be such a cool data set to compare with, early prediction or something like that.
Right.
There's all kind of projects you can do live streaming, step by step, one step at a time. Every week, at least two modules you can develop and probably take it for a longer period of time so that we cover all those things.
Well, something I personally love seeing in projects, and I don't think we've touched on this that much, but people collecting and using and analyzing their own data. I think Dhaval mentioned this about doing a project with your own personal finances, but something like this where you're collecting your health data, you're collecting what you eat and trying to predict, for example, what foods make you feel good or don't feel good. That's an incredibly valuable data science project because it has immediate impact on your life. And talking about those things to employers, I eat that stuff up. So.
Yeah, that's very cool actually. You are your own client actually.
Yeah, and I remember that, Ken, you mentioned something on one of your videos that you use data to drive your golf playing, right? So you're analyzing.
I was basic in Excel back when I was doing it.
Yeah.
That's what got me excited about data science in the first place. I was like, wow, I can actually use this to help improve my own performance. That's the competitive advantage that most other people didn't have. And I was like, wow, where else can you apply this? Can I apply this to make money? Can I apply this to make myself more efficient? The opportunities are endless. So
yeah. All right. Great. So let's move on to lighter questions. So let's focus more on the practicalities. So what are the tools of the trade that you guys use? Let's start with data. So where do you guys go to find data sets? So maybe we could start with Krish.
So first of all, since I'm working for a company, we first of all see that based on one specific product, the company may be having some kind of data. Okay, and suppose we require some kind of weather data or some other data, we basically refer for third-party APIs and we try to find out companies who can actually give those kind of data, because those data is pretty much important and we have to buy it, we have to take it since we are developing a product which may be, involving some costs. So definitely we have to go in that particular phase where we need to buy that specific data. So third-party API is one. People say web scraping we should not do. Again, we may get into something like legal problems. So if you're developing a product for a specific company to sell something or not, So third-party API sources is one, company internal databases, that data can be one. So that is what two common data sources that we usually use. And probably every there will be some third-party companies who will be selling some kind of data. Definitely, I've seen that. Any data that you want, any data, weather data you want, census data you want, everything is actually there by one or the other company who are doing it.
Awesome. Dhaval?
So we, if you talk about Bloomberg, my company, we ourselves are that data provider actually. We are like number one in terms of financial data and analytics. So we just try to scrap a lot of information, which might be free. Like we are talking about company financial reports, 10K, 10Q, like, you know, when companies publish these reports, they are available online to public, all the shareholders. So we try to process those documents and kind of present them in a way that is more consumable via our Bloomberg terminal product. So a lot of this data that the kind of data that I deal with, they are all available in-house because we ourselves are data and analytics provider. And as far as my YouTube projects are concerned, as Krish mentioned, I did this project on the sports personality image classification, and we had written this image scrapping code from Google Images. But you know that Google is always improving their algorithm. So after a while, your code will get stale and it will stop working. So
yeah, the same problem happened with me. Okay, I had actually created an image web scrapper. The image tags got changed. Now, previously, where I was picking the URL, that whole tag got changed. Now many subscribers are saying, Krish, the code is not working. Then I'm telling them that okay, it is because of the change in the tags. Usually Google do that, and many people usually scrap the images and all. So probably we need to update the code again and again.
Google, like, they don't want you to, you know, write like bots against their database. I mean, when I think Bing came along, right? You know that whole story.
Yeah.
The Bing guys tried to scrap Google to index some of that information, and after that, Google really got really strict about it. And any company, you know, if you have a website, you don't want any random bot to be scrapping your data. So this whole web scraping is little like a gray segment nowadays. I mean, people file lawsuits. I think LinkedIn had a lawsuit recently. LinkedIn, I think, filed lawsuit against someone who was doing web scraping, but it's not going to turn into their favor because, you know, the courts will generally rule that it's a public information and you can go and scrap it.
I have heard that some companies are web scrapping LinkedIn jobs to give job alerts to someone. So
I know. Same, like it's have everywhere. We Bloomberg, like we are a data provider, and we sometimes face this issue ourselves, where, you know, like someone will buy a paid subscription, but then person might try to scrap the information, which might not be under legal terms, and then we have to do something to prevent that. So this is the problem that every single data provider in the world is facing today. So, and I think there are, I have not used it, but there are some tools like web scraping enterprise tools. So I don't know how they do it. Maybe they just keep on updating their code every now and then. But in the end, for my sports celebrity project, I ended up using this FatCoon tool, which Ken suggested to me. Thank you, Ken, for that.
Happy to help. Yeah. So from my perspective, my company, we get free access to paid data for sports data sets. So the PGA Tour has a big data set called ShotLink, and then basketball uses a data set called Second Spectrum. For my individual projects, for my YouTube projects, I either try to do free APIs, like Yelp has a free API that you can have access to. There are quite a few other ones, and if you want some data, I'd always just like look to see if there's an API that exists. You know, I do personally scrape some data, and there is, as Dhaval mentioned, some legal gray area around that. So for example, that LinkedIn case that he was describing, they actually ruled that it is legal to scrape data because it is public information. But the way that companies prevent that is they just keep changing the tags, they keep changing the website infrastructure. So the best way to actually understand if a website is web scraping friendly is you search for the robots.txt file. that the websites have. So for example, in LinkedIn's, they have a legal disclaimer, right? That you shouldn't scrape this, we'll press legal action. If you go on the one for Glassdoor, it's frowned upon, but they don't say that they'll press legal action. So I think it's safe to say that like you could use some scraping on the Glassdoor one, even though that it's frowned upon. But that's something you do want to be careful about. I would always look for that robots.txt file. To me, that's like the easiest heuristic. Again, in the US, it should be legal to scrape things, but you do really want to tread carefully. There's some websites that like really welcome it though, right? I did a lot of the basketball analytics website, for example, they're like very easy to scrape, and they're prepared generally because they know people are going to be going through and scraping them. So I think it's just important to really do your due diligence and probably err more on the side of caution there. But again, showing that you can do some scraping is a really valuable skill to have, because you never know when you're going to go out and have to get data. This is less relevant for if you're working in one of these larger multinational corporations because they can pay for data. But if you're working in a startup that's really lean, you're trying to save costs, you might be really providing value to your company, being able to go out and pull some of this data down for free.
Right, awesome. Yeah, so aside from the APIs that you guys have mentioned, I noticed that, like, for example, YouTube, they also have the YouTube data API. And so the thing is, you could request for some token and then do some scraping there. Other data sets, like some about air quality, as Krish has mentioned, I've also tinkered with that as well. I think there's this website called AQICN, and they give you limited capabilities for retrieving data as JSON format on like any air quality location. And a couple of months ago, Google had this Google dataset search. So that might also be interesting to explore as well. But however, in Google dataset search, I've tried that. And the thing is, the quality of the data is, heterogeneous. Some are good, some are not so good. And for perhaps more high quality data, you could look into peer-reviewed journals. For example, the big publisher Nature Springer or Springer Nature, they released a publication called Scientific Data. So in this publication, you could essentially download high quality, large scale data set directly from the publisher. So researchers are generating large amounts of data and they're publishing that and they're sharing that. And another one is from the MDPI, and the journal is called Data. So the term is quite ubiquitous. So maybe you want to type in MDPI and then Data. And Taylor and Francis, the publisher, they released this journal called Big Earth Data. And so you could have access to, like weather or geographical data or earthquake data directly from this journal. It's called Big Earth Data. Okay, so anything else to add, you guys, on the data aspect?
We missed Kaggle and UCA.
Ah, yeah. Kaggle, exactly.
The biggest one.
Yeah.
And Quandl is
Quandl is also there. Yeah,
an alternative
for financial data, I guess. Quandl.
Yes, Quandl is financial, and then Amazon also has some free data. I was just going through that. They have some 157.
I think there is something like Yahoo Finance API is also, which is available completely for free. Like you just have to install the package. Data Streamer, some package name is there in Python, so that will help you to read. Not Data Streamer, sorry, Data Reader. Sorry.
And if we have big pockets, $20,000 a year, we have Bloomberg paid subscription. You will get any information that you can think about in terms of financial.
So, probably we need to get funding 100 times more than that particular amount.
Once we start our hedge fund.
Yeah.
Yeah. Okay, so another tools of the trade. So could you tell us what is your favorite machine learning algorithm? Can we start with Ken?
Sure. So I personally really like, this is going to be kind of basic, but From a business standpoint, I think multiple linear regression is still extremely, extremely valuable. So the reason of that is because of the interpretability. It is, in my opinion, by far the most understandable model to anyone who doesn't necessarily know data science that well. You know, you get the coefficients and you can see the direct impact of the independent variables on the final outcome. And that's something that is very, very powerful. You can kind of hint at this from like feature importances in random forest, or, you know, there's other packages that tell you like more about what variables are have the largest impact, but you can't see that direct relationship between the variables and the outcome. Clearly, I think that that's something like once you have a really firm understanding of that, in almost every model I run, I benchmark off of just a multiple linear regression. And I also use that to explain to any business stakeholders, like, these are the things that are, these are like the levers that you can pull that actually have an impact on the end value. I mean, I think it's really important to be able to productionize these things, really important to be able to, you know, like put them into practice and automate them. But at a very fundamental level, business stakeholders won't implement anything that they don't understand very well. Mm-hmm. So for an explanation tool, I think that multiple linear regression is probably the most clear one out there.
Okay, Dhaval?
I would say logistic regression, because it's kind of multiple linear regression, but you're just applying a sigmoid, and it's probably the simplest neural network that you can think about. And the project that I did for image classification, logistic regression, ended up performing really well. And
one node neural network.
One node neural network, yeah. So if you think about it like neural network, it's just logistic regression is like everywhere. Very powerful.
Krish?
Yeah, I think ensemble machine learning models like random forest and XGBoost, like what I've seen. Okay, if this is the interesting thing, like in my previous company, people who did not know much about random forest and XGBoost also, right? Whenever they used to get a problem statement directly, without thinking anything, they start with random forest regressor or classifier. Okay, whatever problem statement it is. But at the end of the day, this ensemble techniques has become the favorite algorithm for most of the CAGLers, because it performs well for any kind of data set that you give. If you see the understanding of XGBoost or random forest, they work in such a way that with the help of multiple decision trees, they try to handle both the overfitting and underfitting problem statements also. So yes, if you know about that particular algorithm, and if you just do a little bit of hyperparameter tuning, you'll be able to get a wonderful models. My favorite is XGBoost. I don't even go with ADA boost or gradient boosting. I just go with extreme gradient boosting. As the word says, extreme, till the point.
Must work.
Extreme.
So
yeah, well, you know, one huge benefit of so there's two things. I think that people really underestimate the value of randomness in data science. You know, that's not something that people talk that much about. And like when you generalize through randomness, like you're doing in a random forest or an XGBoost, there's a tremendous amount of power in that, because it's effectively simulating a lot of things that could happen, and you're choosing the most probabilistic outcomes. The other nice thing is you don't have to worry about things like multicollinearity as much when you're using a nonlinear model. And so like you can effectively just throw in all your data and you'll still get really good results, because it's splitting based on, you know, based on the largest differences there. So it's kind of like, wow, I can benchmark off this. I don't have to do as much. And I can still get good results to start with. That's such an amazing feeling than like pulling out parameters, like trying to fit these things and worry about what goes into the model as much to start with. So it's always good to get that like quick win, like, oh, this already works pretty well. I just have to improve it a little bit more.
So in this ensemble techniques also internally, there is a voting classifier, you know, like how, suppose internally there are 500 trees being used. And if someone says like 251 trees says, yes, it is one, that basically means for a binary classification, if it says one, then that whole problem statement will be considered as one. That basically means true. So it is a kind of democracy, you can say,
It
so
is, yeah.
this is
I was
a
actually going to mention that. It's like a very democratic way of doing it. It's just that you have to be
yes,
careful about your training budget and all that.
yeah,
Like it might take
yes.
some time
So
and
probably
computational resources.
the first project that I did, I used random forest.
Mhm.
And probably right now it is working then. Recently, I've heard in my previous company, they have moved into deep learning because
Mhm.
now they have a huge amount of data and they have basically implemented an AI and an artificial neural network. And that is what, otherwise, till 2 years back, it was working on random forest. It was working on fine. Yes.
Right. Yeah. So my favorite is partial least squares regression. So I like the aspect that it could compress data, and it also have the flexibility of showing you the regression coefficient. And so the benefit Ken has already mentioned. And aside from that, I also really like random forest, as Krish has mentioned. And so, and Ken mentioned also already, like, you don't really have to do anything. You just dump it in and it does amazing results. And so in our research group, I think for the past 3 years, we have been using random forest exclusively, random forest. And we have great success in interpretability. We look at the feature importance. But the thing about random forest is that for the feature importance, it doesn't tell you the direction, right? As Ken mentioned, does it have a positive or negative effect? So what we did was we did a second step. We do feature importance, and then for the important feature, then we would do like a scatter plot and like the box plot and look at the comparison between two classes. And we look at, okay, whether one class is going have a higher value and the other class might have a lower value. And if moving back like 4 to 5 years ago, we used a lot of partially squares regression. And the reason being is that in chemistry, or chemometric as they call it, so they have a long history. I think it was like 1979. I think it was Svante Vold. He proposed the PLS regression. So he's a chemist and he proposed this. And it was back then that PLS has gained pretty good traction in the field of chemistry. And the advantage is that it handles high dimensional data pretty well. And it also provides you with good interpretability. And so, yeah, so those are two of my favorites. And I have yet to implement deep learning. So, like a couple of years back, I was like, there was a paper published and it says like deep learning provided you only 0.02% improvement for the data in chemistry. And so the thing at the time, I was like, okay, only 0.02%. I mean, that is not worthwhile to implement deep learning. And, fast forward to today, and it's a major mistake on my part. So I never expected that deep learning would have come this far. And so like currently my goal now is to learn more about deep learning. So I'm looking into PyTorch. I'm not sure. What are your guys' recommendation?
So what
PyTorch.
I have done is that, yeah, I've used both TensorFlow, Keras, and PyTorch. So I've gone in this way. First of all, I learned TensorFlow, then I learned Keras. Keras, I found it very much easy. PyTorch, it is with respect to Python. Now, one thing about deep learning is that if you have a huge amount of data, definitely it is going to work in a much more better way when we are comparing with machine learning. Suppose for a particular problem statement, you have less data, then I think you should go with machine learning models.
Yeah.
That is what I believe.
I would say, so TensorFlow and PyTorch, these are like two options. And Keras is just an abstraction API, Keras, I think they now exclusively support TensorFlow only. They don't support PyTorch. So thinking about this, like one is from Facebook, one is from Google, and TensorFlow 1.0 was not very convenient. So at some point, PyTorch started getting more popular than TF 1.0. And these guys realized the mistake. Google guys then released TF 2.0 because they have similar experience when you talk about Angular versus React. I think in Angular, Google did big blunder, and because of they had to pay the price, and now React is the de facto standard when it comes to mobile app development. They probably realized this mistake. They released TF 2.0, which is much more user-friendly. And I was just discussing the same topic with my friend at Amazon, and as per him, they are kind of like neck to neck nowadays.
Yeah, so I really liked the Fast AI deep learning course.
Mm-hmm.
I kind of go through that. I'm gonna start going through that every year. They do some updates. They've built a wrapper around PyTorch, very much like Keras is a wrapper around TensorFlow to make it easy to use. One thing I think they do very well is transfer learning. So Krish was talking about how with big data, deep learning is very valuable, but for smaller data sets, it's not as relevant. With transfer learning, you can start to use smaller data sets because you're already have like a trained model that you're just kind of chopping off the last couple layers of. You do have to have similar problems though, right? So it works great with image classification. So you can train a pretty good model with like 100 pictures if you're using transfer learning, because like what the first majority of the model is trying to understand is what like are the elements of the picture in general, and then the last ones are specializing for the specific picture types you're looking at. But I really like that platform. I've used Keras quite a bit. My first experience with deep learning was in TensorFlow and Keras, but I think what a lot of people need to understand is like deep learning. It's like, wow, this is so advanced, but like the math behind it and like what actually goes on underneath the surface is like very simple comparatively. I mean, just like Dhaval was talking about, it's historically it used to be sigmoid functions. Now we're using, I think it's ReLU.
ReLU is more popular, yeah.
But it's just
fundamentally it's same. Like sometimes people think deep learning is new. I remember I graduated in 2003, and my last year project was image classification using backpropagation algorithm. I implemented that in C++. It is freaking 20-30 year old. It's like really old. Some of the concept I know now we are making improvements in terms of maybe like the APIs and infrastructure. For example, transfer learning, that's something kind of new. Like we are evolving in terms of the paradigm, but in terms of the algorithm itself, they are like quite old.
Yeah, and I mean that's a couple of years ago. I remember hearing someone saying like, look, like algorithms aren't going to change that much, but the volume of data and like the amount that like the size that we can make these neural nets and like the number of layers and like the intricacy is what's really going to change. And so that again goes back to what Krish is saying, is that like if you have a lot of data, the more data in these neural nets, the better, because you can keep adding layers, it keeps adding like very intricate pathways. But I think that compared to some of the other models we're talking about, like I would argue that like the infrastructure of deep learning is like a lot more simple than like a support vector regression. And it's kind of like, hey, like, these things shouldn't be as scary as they are. They're very useful. And like now with Keras, with Fast AI, they're like pretty easy to implement. So, it shouldn't be as intimidating to a lot of people as it might come off on the start.
Yeah, I'll say you why PyTorch has become pretty much famous because it uses the same Python framework, all the syntaxes, how you create classes, everything. It's almost like that. So it has become
very
the
user friendly.
User friendly. Now, one good thing in TensorFlow 2.0 is that Keras is already integrated within the TensorFlow. So before you had to install Keras library separate, TensorFlow library separate. Now you don't have to do that. You just install TensorFlow 2.0. Automatically, the dependency of Keras is also installed. You just have to import TensorFlow. Then you just have to write TensorFlow.keras. all the libraries that you want to basically use. So I think that is the good work they are done. But again, both of them provides almost all the functionalities that is required.
Yeah, awesome. Yeah, so now let's have, I think maybe the final question for today. What is your favorite IDE or coding environment? Yeah, who would like to start?
I'll start with, I like PyCharm. It's amazing. Okay. I like PyCharm. I like VS Code. Well, I started with Spider. Spider was also good because I could see all the variables every time, whenever we do anything. But if you really want to work in the real world industry, VS Code and PyCharm, because you'll be able to debug the code very much properly. Even though the code is in the production, you'll be able to debug it pretty much nicely. So I like this too. PyCharm and VS Code.
Mhm.
And this is with respect to Python. If you are R Studio.
Yep. I personally still use Spider for anything data science related. I actually started with R and then switched over to Python. So like RStudio and Spider are very, very similar. And that was just like being able to see the variables for me. I'm working with smaller data. I have to constantly check stuff. That's the easiest way for me to see it. And, you know, you can pop out the like kind of tabular view, which I really like. If I'm actually doing programming, I also use VS Code. Like if I'm putting anything to production, if I'm like writing scripts, if I'm doing any of that, I really like how VS Code functions. I'll occasionally use like Notepad++ if I just have to like open something really quick. But you know, those two are what are my go-tos. I really don't enjoy using Jupyter notebooks that much. I know that they're very common. And it's I think it's really important to be able to show your analysis and like let someone else work through it. But for my workflow, it just doesn't. I don't like jumping through cells. I like being able to run one line of code at a time and being able to check back.